Hello, this is my video for problem set 3, task 3, to explain what you have to do in this task and all of the different notes and details. So, in this task, we will write code for playing a game against the computer called rock, paper, scissors. And the way that this game works is it's a casual game to be played among people, usually. And it's often used for deciding things like who's going to go first in some other game. And so the way that you play it is you take your hand, you form a fist, take your other hand, you form a flat place, and you can pound your fist. And this is to coordinate that both players are going to reveal a hidden choice at the same time. And that mutual choice is then going to determine who's the winner and who's the loser. So, pound my fist, I say rock, paper, scissors. Now, people play it differently. Some people do rock, paper, scissors. Some people do rock, paper, scissors, shoot. But either on the third pound or the fourth pound, I'm going to turn my hand into a symbol. Now, the three symbols are rock, which I just keep my hand as a fist. So, rock, paper, scissors, shoot. That's rock. Rock, paper, scissors, shoot. I make the V sign with my two fingers like a pair of scissors. This is the scissors play. And then lastly, rock, paper, scissors, shoot. I put my hand flat. That's paper. So I have to choose which of these three symbols I'm going to turn my hand into. And my opponent has to make that choice. And at the count of 4 or 3, we're going to reveal that choice at the same time. So nobody has an advantage, right? And the different choices win or lose to each other. So scissors beats paper because you can cut up the paper. Paper beats rock because you can cover the rock. That's always been a little bit of a mystery to me. And then rock beats scissors. You can crush the scissors with a rock. So that's the game, right? And if you both choose the same thing, like you both choose rock, that's a tie and you have to play again. Sometimes you play best of 2 out of 3 or something like that, and we'll actually get to that in a future problem set. But for this problem set, we're just going to play the game once against a computer. So we're going to make a guess, and the computer is going to randomly choose an option. And then we're going to have the program tell us, did the computer win or did we win, right? And we're going to use input and printing to keep this super simple. So that's our goal. There's an explanation of rock, paper, scissors here that you can read. There's a little graphic that shows how rock beats scissors beats paper beats rock in this kind of circular fashion. Excuse me. And because of the circular nature of the game, there's no choice that's best or better than any other. If your opponent is just choosing randomly, then you might as well choose randomly too. There's a deep strategy to the game if you think you know what your opponent might do and you can sort of outguess them. Especially if you tie, then there's sort of a preemptive like, well, are they going to play the same thing or something else? But since we're playing against the computer, all of that is out the window and we might as well just choose randomly. Here are the functions that you're going to define. And we've actually given you these functions along with documentation strings. So you can use these documentation strings when you define your functions in your file. You could also write your own documentation strings if you want. So, is valid gesture? One of the things that we need to be able to say is, if I'm playing rock, paper, scissors, and you say, oh, I'm going to play whale, or I don't know, glue, that's not a valid gesture. That doesn't count in the scheme of the game. And I need to be able to say, wait a second, that wasn't a valid gesture. We need to like do over or something. So this function is a predicate. And in fact, this task 3 is the first task for problem set 3, where we'll be using the notion of booleans and conditionals to make things work. So this function is a predicate. That means it returns true or false. It's given gesture as an argument, and gesture is going to be expressed as a string in Python. So we'll use the string rock, paper, or scissors. What gesture is valid gesture is supposed to do is return true if the gesture is one of rock, paper, or scissors, and false otherwise. So express that as a predicate, right? We've had practice with those. And that's our isValidGesture function. Now, the computer needs to be able to pick a gesture. So you need to define a random gesture function. And this must randomly return one of rock, paper, or scissors with equal probability. So it shouldn't be like 75% of the time scissors, right? It should be like 1/3, 1/3, 1/3 rock, paper, or scissors. And I'll get to how you can do that in a second. Beats is another function that we need to define. And this is going to be like the core logic of our game, right? So I explained how rock beats scissors and scissors beats paper and paper beats rock. Well, this beats function is going to implement that for us. So it takes two gestures, gesture 1 and gesture 2. And it's going to return true if the first gesture beats the second gesture. Right? We don't care if the second gesture beats the first gesture. I just care if the first gesture beats the second gesture. And it's going to return false otherwise. And this function is going to assume that it has valid gestures, right? It's going to say, it's not my responsibility to check whether it's whale or something else here. If that happens, I can't guarantee anything about what I will do. But if you give me rock, paper, or scissors and rock, paper, or scissors, then I will tell you, true or false, does this first gesture beat this second gesture? All right. So the play function. Again, we have two arguments here, your gesture and the opponent gesture. And so this function is going to play the game, right, with your gesture, the opponent gesture, and these functions, isValidGesture, random gesture, and beats, they're all fruitful. Play is not fruitful. It is a function that prints some messages depending on who wins, right? So if both gestures are valid, it's going to display one of game is a tie, or you win, or opponent wins, depending on, these two gestures. If your gesture is rock and opponent gesture is scissors, then it should say you win. If your gesture is rock, opponent gesture is paper, it should say the opponent wins. If you both choose scissors, right, it should say that the game is a tie. And if the gestures are somehow invalid, then it's going to give us a message, either that your gesture is invalid or that the opponent gesture is invalid. If they're both invalid, then it'll simply say that your gesture is invalid. So this function has some kind of logic to it. You'll have to use conditionals to figure out how to do that, right? Finally, play computer. So play computer takes one parameter, which is your gesture, and then it's actually going to do the same thing that play did by printing out a result of the game. Before that, it's going to display the choice of the computer. So you give it a gesture, it says, okay, you gave me your gesture, here's what the computer chose, and then it prints out the results of a game. Now, play computer should not include the same code that play does, right? Instead, we have this function sitting here. We should call play from within play computer. And also, we should call random gesture from within play computer. All right. So one way to test your functions is to run your program and then try some things in the shell and Thani, right? So here's some examples of results that you might get for various different kinds of function calls. Of course, random gesture is not dependable. You're just going to have to test it a bunch of times to make sure it gives you all three different options randomly. Here's some tests for the functions that print things. So play is going to print one of these kind of messages. Or like if we give it rook instead of rock, it might print your gesture is invalid, right? And actually shows us the gesture that was invalid. And then play computer has this random element, right? You might get a different printout because of randomness, but here's an example. If we play and we choose paper, and if the computer randomly chooses rock, then it'll print you win. All right. There's some automatic testing that we have included in our testing code. This actually may not be accurate to the starter file anymore. I think we've moved this into a test function. But we still have the main conditional block that triggers that test function. And in that test function, again, you can comment things, you can add print statements, whatever, as long as you keep it in that test function. All right, some notes to help you get through this stuff. First note is relevant to how do we do that random gesture function. There's a function called random.randint for random integer. We can give it two numbers, a and b, and it'll give us a randomly chosen integer between those two numbers, including those two endpoints. So if I say random.randint 1, 10 is going to return an integer 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it's going to be equal probability for all of those results. Our starter file already includes import random, so this is the function you should use along with a conditional to implement that isValid gesture, or sorry, the random gesture function. This note is talking about this do not repeat yourself or don't repeat yourself principle in computer science, right? Which is saying if you've got a function that does something, I don't want to see you copy pasting that code. Just call that function to do the work, right? So you should call beats within play because play needs to know which gesture beats which other gesture, and we have a beats function that tells us that already, right? All right. The last note is just about this variant rock, paper, scissors, lizards box that makes things more complicated, but I'm not going to go into that. The last thing I want to do for this video is go into our rubric for task 3. So, what are the actual goals that we're grading you on, right? Goal number 1, isValid gesture better give us correct results, and we have 4 tests for that. Beats had better give us correct results, and we have 6 tests for that. Random gesture must return each possible gesture, and it had better be about 1/3 of the time each. Play computer has to print the correct output. Play has to print the correct output, right? These ones are printing, not results that are returned. And again, we have several different tests for that. All right, isValid gesture. And again, the play computer result, right, that's random. So we're going to test with either a fixed randomness or we're going to do a bunch of tests to make sure that on average it works. All right, how do you define these functions? So these are more core goals about how you do it. No requirements for isValid gesture. You just have to define a function of that name, right? And of course it has to be correct. That's the other goal. In random gesture, you have to call random.randint, right? In beats, no requirements for how you define that function. In play, this is more specific. You have to call beats, you have to call isValid gesture, you have to call print, and you have to use conditionals, right? Here there's no requirement on how many for the core goal. There's also, for isValid gesture, you have to call it in at least 2 places, right? Because you have 2 gestures that you need to check whether they're valid. All right, and then for play computer, well, we have to call random gesture, we have to call print, and we have to call play. So those are our core goals. How about the extra goals? Well, we have more tests for isValid gesture, more tests for beats. Here's the requirement. So random gesture has to return the different possibilities about 1/3 of the time each. And we test this, I think it's like 10,000 times or something, to make sure that even if the randomness is, you're unlucky a little bit, it'll still be about 1/3 of the time. Play computer prints the correct result, right? And so this is more tests for that, more tests for play, right? With some sort of more tricky inputs. All right, we have to define isValid gesture, and the extra goal requires that you do not use any if statements, right? This is a predicate. We don't really need conditionals to define our predicates most of the time. And so don't use any if statements in isValid gesture for the extra goal. Calling random.randint exactly once is an extra goal for random gesture. Not that it would be that useful to call it more than once, but who knows what people want to do. Defining beats, again, without any if statements. That's our extra goal here. You do not need conditionals to write most predicates. If you have a good understanding of what it means to return a Boolean value, and how those like comparison operators really convert things to Boolean values. All right, in play, what are our extra goals? Well, calling beats in at most 2 places is an extra goal. Calling isValidGesture in at most 2 places is an extra goal. So that would be exactly 2 if you also did the core goal. And calling print in exactly 5 places is an extra goal, which generally speaking, because of the number of things you have to print, you should already be doing that. Play computer, calling beats is not something that you should call in play computer. That's an extra goal, so we're lenient if you do that for some reason, but it's not something that you should call in play computer. And then again, do not call isValidGesture in play computer either. These tasks should be handled by play, not by play computer. All right, that's problem set 3, task 3. And I will stop the recording.